In this video, I want to show you how to use Ncase to analyze an NTFS file system. And in class, we also mentioned about that $MFT, and each file has an entry in $MFT, and a small size file will even have the content reside inside of an MFT entry. So I want to demonstrate this in this video. Now currently I have my Ncase open and previewing my Windows 7 image, and I did a green highlight on the drive C drive, and then you see this is the content of C drive only, because otherwise there's a lot of other content. I don't want to see that, so only I want to see the content from the drive C. If you look at the file name, many file names start with $. Those are system files in NTFS file system. In the class, we talk about $bitmap. We talk about $MFT and the $MFT mirror. And those are the system files. You can see that. Let's look into the timestamps for. If you look at those timestamps for the system files, interestingly, they are all same. Okay, those timestamps for the system files, they generated when NTFS file system is formatted, and those never change again. So as a forensics investigator, if you see those timestamps, you know this file system is formatted during that time. If you see it's very recent time, and then that should give you a signal the person has reformatted the file system. Okay, so that's great information to know. Now, especially I want to show you the $MFT and the $MFT mirror. So $MFT mirror, it is mirroring number of files in the $MFT. So here I highlighted on $MFT mirror, because you see this is the blue line. I highlight on that. If you look at the text view here, now a bunch of things is not able to read, but if you see this is the starting header file 0, if you highlight until hit the next header file 0, this is one entry, one entry for $MFT, because each file has an entry in $MFT, and this is one entry. The size you can see here, size is 1024. Size 1024, and from the lecture you should know inside of this 1024 bytes, they specify the file name, which is used to 255 bytes, and with standard information and with cluster information and all that within this 1024. Now we cannot read much, but we can see the file names in that. So this is the first file actually in $MFT, and that's saved in the mirror. So $MFT. Okay, that's the first file. And the next file, it's saved in that. If you look at the next file 0, if you look through, that's the $MFT mirror. Okay, and then the third one is $log file, and then the fourth one is $volume. Now, by examining that, you know $MFT mirror only copies the first 4 files entry from $MFT, and you should be familiar with this looking of the content. If you look at the file 0, those are the entries for $MFT entries. Next, I want to look at a small file, hopefully to see this small file resides inside of this 1024 bytes. To see that, I have one small file on my desktop. It is called FTK password. If I open it up, this is a text file. Very simple. Just say username is admin and then password is NetSys, and then username student and student. So that's the file. The size is certainly very small. And we want to see if this file's content, the data, is reside within a $MFT entry. So first, let's find that file. Okay, shift a little bit, and then I want to see this file is on the desktop, so it's under D drive, user, student. So let me highlight student and the desktop. Let me only want to see the desktop. Okay, so I only want to see the desktop and entry here, and then I need to find the called FTK password. Now a lot of files listed here, so let me try a trick here. So if I can type FTK, no, yeah, so it will try to look for it so this is the FTK password file. If I highlight this file, now you can see its content: username, admin, password, NetSys, and the username student, and then certainly it tells you this is the FTK password.txt, but I still cannot prove this is inside of MFT. But when you click on other one, you will see this file, it looks different. Like this is very clean, only have one line, nothing else. But nevertheless, let's try to find whether this is inside of MFT. So I click the first character, highlight on that, and I go to the disk view. Now this content certainly is reside in this disk, in this sector, because I clicked it and I going back to disk view. This is the one highlighted. Now I need to find whether this content is inside of that. Okay. If you are familiar with this $MFT, probably you already know this. This is all start from file 0. This is inside of MFT. $MFT content, but then we need to find the data is in that. Now you see here, this is the data, okay, and inside of entry, $MFT entry, 1024, okay, that whole thing I think is 1024. Yeah, so this is one entry for that small file. Okay, the file name is called FTK password file, and then the content is inside of $MFT. So in this case, inside of $MFT entry. In this case, Windows the file system needn't save cluster information because it's just tiny bit content. And they can have up to 700 bytes of content to be directly effectively just inside of this MFT entry. It's good enough. You needn't allocate cluster to be outside of this record. Okay, so that proves small files data content resides in $MFT entry. Okay, so hopefully you enjoy this video, and then I will end up here.